A simple way to classify observations into two classes is to draw a linear boundary between them. However, even if the data is perfectly separable in this way, there are many possible linear boundaries that could be used. Which is the best? One approach is to use some kind of statistical distribution fit. However, this means that even points far from the boundary have an influence on where the boundary is located. Intuitively, it seems like a better approach for this kind of problem would be to put the boundary as far as possible from any of the observations. This is the basic idea behind support vector machine classification. If the data is actually linearly separable, this results in a simple optimization problem. Choose the coefficients of the linear boundary to maximize the margin, that is, the distance between the boundary and the nearest observations, subject to the constraint that all observations must be on the correct side of the boundary. Note that, in the end, the optimal solution is determined only by the observations nearest to the boundary. These observations are referred to as the support vectors. Real noisy data may not be linearly separable. That is, there is no linear boundary that can correctly classify every observation. In this case, we can modify the optimization problem to maximize the margin, but with a penalty term for misclassified observations. Note that observations are correctly classified only if they lie on the correct side of the margin. So the penalty term prevents a solution that cheats by having a huge margin. The SVM solution, then, is the one that gives the best possible separation between classes. That is, the widest margin without unnecessary misclassifications. Linear boundaries between classes are not appropriate for all problems. However, SVMs can still be used on nonlinear classification problems by performing a transformation of variables into a space where the classes are linearly separable. The linear boundary in that space is equivalent to a nonlinear boundary back in the original variable space. Note that the SVM formulation works only for binary classification problems. Multi-class problems are solved by combining multiple binary classifiers.